Hi students, this is Alex here. In this problem, they are asking to find the displacement of a string of length L vibrating between fixed endpoints with initial velocity 0 and initial displacement is given by. So let's write the boundary conditions and initial conditions. First condition is we have a fixed end. So displacement at x is 0 for all t is 0. That is, whenever t is greater than 0 and the displacement is 0 at x is 0. In the same way, the displacement when x is L, it is the other end. So that is also 0 for t greater than 0. And the third is we have the initial velocity, that is dou y by dou t. Since it is the initial velocity when time is 0, so this is 0 for 0 less than x less than L. And finally, we have a initial displacement which is given as a function. This is the fourth condition, that is y of x comma 0 equal to, we have 2px by L, 0 less than x less than L by 2, and other is 2p minus 2px by L for L by 2 less than x less than L. So we have this. Now let's write the wave equation. The wave equation is dou square y by dou t square equal to a square into dou square y by dou x square. So according to this equation, we have three types of solution, but suitable solution for these boundary conditions we are going to take. The suitable solution is y of x comma t equal to c1 cos px plus c2 sin px into c3 cos pat plus c4 sin pat. Now we are going to use the first condition. So using the first condition, y of 0 comma t is 0. So wherever x is there, we have to substitute 0. So y of 0 comma t equal to, so here I put 0. So here if I put 0, I get c1 because cos 0 is 1 and here sin 0 is 0. So we left with only c1 into c3 and t is t itself. So cos pat plus c4 sin pat. Now y of 0 comma t, the condition value is 0. So 0 equal to c1 into c3 cos pat plus c4 sin pat. And here this c3 cos pat plus c4 sin pat cannot be 0 because it is defined for all the values of t. Therefore c1 must be 0. So after getting c1 as 0, we are going to substitute that in the initial solution. So we get y of x comma t equal to, since c1 is 0, we left with only c2 sin px into c3 cos pat plus c4 sin pat. Now we are going to use the second condition using y of L comma t equal to 0. So wherever x is there, we have to put L. So y of L comma t. So here I replaced L equal to c2 sin pl and t is as it is c3 cos pat plus c4 sin pat. Now y of L comma T is 0. So 0 equal to C2 sine PL into C3 cos PAT plus C4 sine PAT. When this is 0, definitely this term cannot be 0, which we already discussed. So here either C2 equal to 0 or sine PL equal to 0, because the other term is not equal to 0. But already C1 is 0. Therefore, C2 cannot be 0 now, because both the constants cannot be 0. Hence, we take only the other choice, that is sine PL equal to 0. It means when sine theta equal to 0, theta is n pi. So, this is like theta. So, PL equal to n pi, and from this we get the value of P, which is n pi by L. So this again we are going to substitute in our solution. So y of x comma t equal to C2 into sine px. So sine p is n pi x by L into C3 cos PAT. So n pi at by L plus C4 sine PAT. So sine n pi by L at. So wherever we had P, we substituted. Actually, it is here. We substituted n pi by L. So C2 sine n pi by L into x, C3 into cos n pi by L at plus C4 into sine n pi by L at. So we got the solution. Now we are going to apply the third condition, but for that I need its derivative. So I am going to find dou y by dou t at x comma t. So x is a constant because we are differentiating partially with respect to t. So this first term C2 into sine n pi x by L will stay as it is. This differentiation, C3 is a constant, cos differentiation is minus sine. So minus sine n pi at by L into n pi a by L. Similarly, the next term is C4, sine differentiation is cos. So cos n pi at by L into n pi a by L. So after this, we are going to apply the third condition, that is dou y by dou t of x comma 0 is 0. So let's write here using dou y by dou t of x comma 0 is 0. So initial condition, that is t is 0. So I'm going to apply wherever t is there 0 here. So dou y by dou t of x comma 0 will be C2 sine n pi x by L. Then here when t is 0, the entire term is 0. When t is 0, cos 0 is 1. So we left with C4 into n pi a by L. So from this, we can use this condition, that is this value 0. So 0 equal to C2 sine n pi x by L into C4 n pi a by L. So here C2 cannot be 0, which we discussed already, and sine n pi x by L cannot be 0 because it is defined for all the values of x, and n pi a by L is all constant which cannot be 0. Therefore, the only choice is C4 must be 0. So when C4 is 0, this we are going to apply in the solution. So our solution y of x comma t is, so what is the solution we have? That is here. Y of x comma t is here. So this C4 is 0. So we left with C2 sine, actually here, C2 sine n pi x by L, C2 sine n pi x by L. Then here C3 cos n pi at by L and C4 is 0, so the rest of the terms are 0. So we have this, and we can combine C2 and C3 as the constant Cn. So y of x comma t will become summation ns from 1 to infinity Cn into, actually we can write the rest of the terms as it is, that is sine n pi x by L into cos n pi at by L. Now in this we are going to apply the last condition, that is the y of x comma 0. So y of x comma 0 equal to, using the fourth condition, using fourth condition. So here summation n is from 1 to infinity Cn and t is 0. So we have only sine n pi x by L and cos 0 is 1. So this is what we have, and y of x comma 0 they gave a function which is 2px by L, which is 2px by L when 0 less than x less than L by 2, and it is 2p minus 2px by L when L by 2 less than x less than L, and this is a y of x comma 0. And now we can write summation 1 to infinity this as bn because it is the half range Fourier sine series. So into sine n pi x by L. From this we are going to find bn using the formula 2 by L integral 0 to L f of x into sine n pi x by L dx. Now let's substitute the f of x here, but f of x is made up of two parts. So bn equal to 2 by L integral 0 to L by 2 first I have to take, and f of x is 2px by L into sine n pi x by L dx plus integral, and we have 2 by L outside, so let's keep that again, integral L by 2 till L, and this time f of x is 2p minus 2px by L into sine n pi x by L dx. So we are going to use Bernoulli's formula. So here this is u and this is v, and I can take only x as u, or I can take 2px by L as u itself, because here also we have the terms 2p and L everything. So I'll take u equal to 2px by L and v equal to sine n pi x by L. So u dash will be, its differentiation is 2p by L alone because x's differentiation is 1, and u double dash will become 0. So here its differentiation, successive integration we have to do. So this is minus cos n pi x by L by n pi by L, and v2 will be minus sine n pi x by L by n pi by L whole square. In the same way, here I am going to take u and v. So u equal to 2p minus 2px by L, and v is sine n pi x by L. So u dash will be minus 2p by L, and u double dash will be 0. So V1 will be minus cos n pi x by L by n pi by L, and V2 will be minus sin n pi x by L by n pi by L whole square. Now the Bernoulli's formula we are going to apply is u V1 minus u dash V2 plus u double dash V3 dot dot dot. So for the first term we have 2 by L outside. So Bn equal to 2 by L. U is 2p x by L. V1 is minus cos n pi x by L by n pi by L, minus u dash is 2p by L, and V2 is minus sin n pi x by L by n pi by L whole square, and for this the limit is 0 to L by 2, plus again we have 2 by L, and this time it is 2p minus 2p x by L into minus cos n pi x by n pi x by L by n pi by L. Then u dash is minus 2p by L. Already there is a minus sign here. So now it will become plus 2p by L into minus sin n pi x by L by n pi by L whole square. And now the limit is from L by 2 till L. Now let's apply the upper limit. So when I substitute L by 2 here and here, we get Bn equal to 2 by L 2p L by 2, and already there is one L, so this gets cancelled. We left with only p into minus cos n pi. When I put L by 2, LL gets cancelled, so we get cos n pi by 2. Similarly, if I put L by 2 here, what happens is minus 2p by L into minus sin n pi. After cancelling L, we left with n pi by 2 by n pi by L whole square. When I apply the lower limit, this part is 0 because of x, this part is 0 because of sine. So we have only this much. Lower limit is completely 0. Coming to the second set of terms, we have again 2 by L outside. When I substitute L here, this will become LL cancel, 2p minus 2p is 0. When I put L here, after cancelling L, we get sin n pi, which is 0. So upper limit is completely 0 minus bracket open, we have to apply the lower limit. So here L by 2 will come. So we have 2p minus 2p into L by 2, and there is another L. So after cancelling this, we left with 2p minus p into, we have to write the L by 2 here again. So when I put L by 2, so let's write this here, minus cos n pi by 2 we get by n pi by L. So even here, this n pi by L should come, denominator. Then coming to the second part, when I put L by 2 here, this will become plus 2p by L into minus sin n pi by 2 by n pi by L whole square. Now totally we can take 2 by L common. So first term is, here we have only p, there is a minus sign. So minus p into cos n pi by 2 by n pi by L. And second term is plus 2p by L into sine n pi by 2 by n pi by L whole square. And here 2p minus p is p. There is a minus sign. We can cancel these two. So plus p into cos n pi by 2 by n pi by L. Then here actually this minus sign is common, so we cancel it here, but this minus sign comes inside of this. It will become plus 2p by L into sine n pi by 2 by n pi by L whole square. Now we see these two terms, minus p cos n pi by 2 by n pi by L plus p cos n pi by 2 by n pi by L. We can cancel. Now the rest of the terms we are going to add. So 2 by L, which is 4p by L into sine n pi by 2 by n square pi square by L square. That L square we can carry to numerator. L into L square, so we can cancel this totally. So we get 8p by n square pi square into sine n pi by 2. So we have Bn. After getting this Bn, we are going to substitute in y of x comma t. So y of x comma t will be summation n is from 1 to infinity Bn. Bn is 8p by n square pi square into sine n pi by 2. That is, we have to substitute here. This is our Bn, sine n pi x by L cos n pi at by L. So here it is sine n pi x by L cos n pi at by L. So from this we can take the constants outside. So y of x comma t will be 8p by pi square is a constant that can be taken out. We have summation from n is equal to 1 to infinity, then sine n pi by 2 into sine n pi x by L into cos n pi at by L. So this is the required solution. And this n square also we have to write, because this n square is not taken outside. So we write 1 by n square here.